There's no doubt that models of lung disease are an important tool for translational research. However, there are a number of challenges. First of all, the lung architecture matters. So going in vitro cells on a dish are not always that reflective of the complex situation in the lung. For example, mouse lungs are not the same as human lungs in terms of their anatomy of the airways, the cells that are present. And also extracellular matrix has an important role, not only for the architecture and the structure, but also it's a bioactive compound. Secondly, the lung is a complex organ. It has many different cell types, and it's actually part of the immune system, and not just simply where air exchange happens. If that's not reflected in your model, it's going to be less predictive. And third, biomechanical forces. We know that biomechanical forces such as stretch, as well as things like the air-liquid interface, really helps to make in vitro cells differentiate and become more reflective of cells that you would see, for example, in a biopsy. But there's hope. There are a number of horizons, I would call them, of things that are happening that to keep in mind, because if we work together in consortium projects or as multidisciplinary teams, there's really the potential that these trends can narrow the translational gap. Now, the first, it's not really a model, it's the SARS-CoV, or the COVID pandemic, simply because that's really fueling a lot of development of new models of lung disease. Second is increasing complexity, adding cells, reflecting the immune system. Third is the ability to scale. When you can scale, you can do screens, and that can really accelerate the testing of different candidate therapies. Third is precision medicine, being able to use patient cells in a model and or being able to test individual therapies on those patient cells is really a trend that can really potentially accelerate the way we can target medicines. And third is a long on-standing trend, but still very important, which is the shift from in vivo to in vitro. That's a shift from animal models to models that are hopefully more reflective. So with these trends in mind, here is what my take on what are the top 5 emerging approaching, looking to the future, top 5 emerging approaches. The first is microphysiological systems, which is the technical term for lung on a chip. These are adding the complexity, they can scale, and they can potentially add that precision medicine aspect to it. Second is organoids. Just because organoids are mini lungs in 3D and allow a much better representation of what's actually happening within a lung. Third is precision cut lung, because they give you that architecture, they give you the ability to do imaging. And then fourth, not really a model, but a technique, single cell sequencing, because that has the potential to help us understand the complex cellular interactions that happen in the lung. And then fifth is the humanized mouse lung, simply because it's difficult to escape using mice, and if we can make them more humanized, they can become more relevant and useful. That's my top 5. If you have other emerging approaches, I'd love to hear about them. But I'd like to just end very quickly with a tip, and that's for an upcoming conference put on by the Fraunhofer Institute, Models of Lung Disease 2021, a special edition focused on corona, so not only just about models, but also about the corona disease and how you can reflect that in lung models. It's being organized by someone I know quite well, Armin Braun. He was central in the EuBioPREP project. He's also part of the IMSAVAR project, which is Immune Safety Avatar. And it's just a great opportunity not only to learn about coronavirus, but to present your own research. And just as a reminder, the poster abstract deadline is coming up very soon, January 6th.